So, welcome to Python Epiphanies. This is a tutorial that I presented in similar form last year and went fairly well. Got a lot of good feedback. My goal with this tutorial is to try to help you understand some things that you don't quite understand yet. And hopefully, again, there's a range of where you're at, and I'm sort of shooting for the middle, so a few of you might not learn as much as you'd hoped, and others, well, you won't quite keep up with some of it. But in general, a lot of people, they start using Python, they think they get it, it's easy, it's fun, it makes sense, and then they keep running into little things where it's like, oh, why did it do that way? What's going on here? I don't quite get it. You feel like you're an outsider. And over the years, teaching people to use Python and then watching them after they've learned Python and how they still struggle, that was the inspiration for this tutorial. The format of the tutorial, we will be using the interactive prompt a lot. You'll notice I've got several hundred lines of code that I'm going to be typing into the interactive, read eval print loop at Python, except fortunately for your sake, I'll be doing it with this button here using some code I wrote, so you won't have to wait while I struggle. Any questions before we get started? Everyone, you'll need a handout for some of the sections. Okay, let's start with, the first thing I want to do is think a lot the next little while about namespaces in Python. Many of you have learned or have programmed in other languages where you talk a lot about variables, and a variable is a box, and you put something in the box, and you have to reserve space for the contents of the box. And earlier, in terms of the history, before in compiled languages, not only do you have to put something in the box, you have to know ahead of time what it is. Is it a float? Is it an int? Is it a character? So when you do an addition operation, for example, the compiler can put machine code, spit out machine code that actually does the right thing, because it's a different machine code to add two floating point numbers than to add two integer numbers. So type declarations were required. Python's an interpreted language, and the way variables and names and references work is different than some of you have thought about. So I'm starting with a little exercise here to get you thinking about dictionaries, namespaces. Namespaces are implemented with things very much like dictionaries in Python. So, first of all, a list maps, you know what a list is, it just maps from integers starting at 0, increasing to objects with some negative ones thrown in for fun. And here's an example of how you access lists in Python. All right, we've got, and I put a none in front of there because they're 0 indexed, and so I want month number 1 to be January. A dictionary maps any object almost to any other objects, and so here's a dictionary that maps the other direction. Okay, no surprise there, you've seen all this. Here's how namespaces work in Python, and I'm going to, they're like dictionaries, they map names to objects. Okay? Just like my namespace here, this dictionary is going to be mapping names to objects. So I create the dictionary, it's got nothing in it, and be patient, this will speed up. Like this right now, you might be like, this is so slow. I'm trying to get you thinking a certain way to get rid of some other ways of thinking you probably have collected over the years. So if I put a key value pair into my namespace, I can check it and I can see the contents, it's got the key value pair. I can access via key and get back the value. I can overwrite the value that's associated with the key that's already in there, and it shows up the change. I can put another key in, another value, right? I mean, none of this is terribly surprising. I can get rid of a key, and then the key value pair goes away. And if I try to access a key that's not in the dictionary, of course it goes away. It gives you an error, key error in this case. Okay, with that in your head, and if you want to see further up, you can look at your handout to see if you want to refer back. I'm going to do exactly the same thing with a namespace, the global namespace at the Python interactive prompt, right? A equals 7. So this is an object. 7 is a literal. It got turned into an object in Python's memory system, and I've assigned a new name. I've created a new name in the local namespace which refers to that object. It references that object. Okay? I can look at what's in my dictionary, my current namespace. You could ignore the built-ins and see, oh, when I declare that, when I say A equals 7, it inserts a key in the local namespace dictionary automatically, obviously. I can reference it, I can dereference it, I can overwrite the value, see what it is. I can add another key value pair. I can look at the keys, and I can get rid of keys. Okay? And when I try to access a value that's not in the namespace, I get a name error instead of a key error. So think of dictionaries when you're thinking about how namespaces work in Python. It will help you. And then, how do we do? Here's just quickly another example. I can have nested namespaces in with a dictionary. I just have a dictionary which holds another dictionary which holds keys and values, right? And if I want to do this in Python, here's a simple way to give me a simple little namespace I can start accessing. Right? It doesn't work exactly the same, but the point is these are just names that are referencing objects. Okay? Okay, so that's namespaces. Just a little shift your focus or your way of thinking about them, hopefully. I'm going to run through this next section sort of quickly, but just some sort of theoretical foundation about objects in Python, things you should know that will help you, I think. Everything in Python is an object. It has a single value, it has a single type, it has some number of attributes, which you access with dot notation. It has a single ID, which you almost never have to worry about. It's basically a memory address. It has one or more names, and those names might exist in multiple namespaces, right? So I might have A refers to this integer 7, and I might have B, which refers to the same integer 7. And it has one or more base classes. Okay? So let me just, I'm going to fly through this section. It's one of the ones that it's there sort of for reference. But here are some examples of objects. And these are all objects that you can enter with literals in the Python interpreter. All right? So a bunch of objects. They all have a type. You can ask what the type of an object is using the type function call. They all have some number of attributes. Dir is a built-in function that if you pass it an object, it will show you most of the attributes of that object. And these attributes, most of them don't actually live in memory on the object. They're chased down through our references to superclasses. Okay, here's kind of a funky thing. I can't get that one because it sees the dot and says, are you trying to make a floating point number? But you can access attributes with the dot of the object. So here are some attributes of the integer 1, or the float. Right? So you can see that the dunder class, that's double underscore class double underscore, dunder class of hello is the same as its type. All right, what's this? Mississippi.count. This is a string, dot count. I'm saying show me the attribute of this string object. The string object doesn't actually have count right in it, but it follows it through to a superclass, which is string, and says, oh yeah, there's a count method up there. Built-in method count of the string object up there, of this string object. Okay, and I can call it, of course, to get a number. So I'm just looking at the attributes here. I'm not calling these ones, obviously. And it has IDs, right? So every object has an ID, which is in CPython is just its memory location. And one or more base classes. So for example, the base class in Python 2.7, if I have a string hello, its type is str, and its super type is base string, and its super type is object. So there's an object tree that's in Python, every object somewhere in the object tree. So what I'm showing you here is this is how this one works. So why did we lose the presentation? Something flashed when you did that.
Actually feels it's gone out. Yeah, the power is gone out. Oh, great. That's power to the podium.
Comes back.
There we go.
Tell me when I can go. Okay, so that will have a couple things in there that are interesting. Let me show you some of them. So you saw how dir works. None of these are surprises. So this one might have been a surprise. So the ID is the memory address of an object. And you can see that when the Python compiler, as part of the interpreter, saw the 1 literal, it went off and created an object, which is the integer 1, which represents the integer 1. And it put it at this memory location. And here we created, you would think, a new object, which is the integer 1. Python actually went out first and said, oh, I've already got the integer 1 created. I'm not going to create it again. Why waste the memory and time to do so? And so that's why when we look at the ID of j, these IDs are exactly the same. So we have I and j both pointing to the same object. Now, that might be dangerous, right? Because if you've got two names pointing to the same object, I didn't ask it to do that. What if I change one? Will the other change? You don't need to worry about that because integers are immutable. Strings are immutable. Tuples are mostly immutable. And that's why they are. That's why Python can do that safely. And it does so for efficiency reasons. Okay? So if you try to, obviously you say 1 equals 2. You can't change the value of 1. It's always going to be a 1. And Python keeps it in a pool. And the is, these are pretty much equivalent. If the IDs are the same, then is true. Is equal means do these two objects have the same value, depending on the definition of the same, which can vary from object to object. Whereas is means are these two objects the same? In other words, does the name I, when you dereference it to the object it refers to, and the name j, when you dereference it to the object it refers to, are those the same object or are they different objects? Not whether or not they are have equal value. Okay? So we're going to skip to the end of this section, and I'm going to talk a little bit about namespaces more formally. So a namespace is a mapping from valid identifier names to objects, like a dictionary. Assignment is a namespace operation. That's what I'm trying to get into your head. And once you get that, a bunch of stuff becomes more clear. A bunch of questions you may have had or that other people have. This is the right way, I think, to tell them, no, that's not a meaningful question because assignment is just a namespace operation. Okay? Assignment is not an operation on the variables or objects behind the scenes. You're only changing names in the namespace. Scope is a section of Python code where a namespace is directly accessible. You access it just by typing its name or putting it in your code, and it accesses that key to get the value. The direct namespace search order is, first it looks the innermost scope for local names, second enclosing functions, third current module global names, fourth the outermost scope. Okay, so that's exactly how namespace searches work. Here are the 5 ways you can change a namespace in Python. assignment, which you've seen, a equals 1. Import, def to create a function, class to create a class, and del, which removes an item from a namespace. Well, that's one of the things it does. Okay? Let me show you the namespace. Yeah, I got those. So len is a built-in function. What if I create a new function, f1, and I define len as a function in there, and inside there I create a local variable len, and I return it, and then I call that function and return it when I call f1. Okay? If you go back and look at the handout, you'll see the exact rules. You should be able to figure out that, first of all, this does something, it doesn't complain, and you can figure out what it's going to do, right? Is that first, this gets executed in f1, len equals this function, right? So at this line of code, the name len refers to this function. In f1's len, so in other words, right in here, len refers to the list, right? Okay, this one's similar, but I don't use a local variable here. And if I call it, you'll see that now right here, len is, of course, the function. So that's the next thing it finds if there's not a local variable. So it's referring, inside this function, we say, oh yeah, len refers to me, right? Now this is kind of interesting. Oh no, so now we've built in function len. I can, at the global namespace, I can override it, right? It's just a name referring to, in this case, this len is just a name referring to a function. It's an object out there, which is a function. I can override it, and now len is 99. Now the len name refers to a different object, which is 99. And if I delete that from my local namespace, I've unhidden the len function, which is a built-in, okay? Usually you should not be using len in any of your code because it's not a keyword, but it's already used. It's a built-in function, so avoid it. But that you can do that, and someone who naively can do that, and then stuff doesn't work quite the right way. I mean, you can, within the namespace. Okay. Pass is not a built-in function. It's a keyword, and I get an invalid syntax when I try to use it. Right? So there's the difference between len is a built-in, pass is a keyword, which means it's part of the compilation. At compilation time, there are reserved words you cannot use for anything else. Similarly, del you can't use without the right syntax, which is it needs to have an argument. Okay? These are the keywords in Python. They're in the standard documentation. So these are the ones that you can't override. You can't change. And you shouldn't change any of the ones that are built-ins either, generally speaking. Okay. So with what we know so far, let's look at some odd behavior. What will test1? When I call test1, it should show us in test1 x is equal to 1. And it does. Good. All right, so in here, we referred to this name, and it went outside the scope of the function to find the global name in the enclosing scope. Okay, how about here? X is still 1. When I call test2, what's going to get printed? Here, I create a new name in the scope of the function, and I refer to that name, and I'm going to get, it's going to show me the 2. All right, it's going to show me the value of the object that got created and assigned to that name when I did this statement. And back out here, well, that function's gone away, the name has gone away, and the global x, or the enclosing scope's x, is still there. X is 1. What's this going to do? What's that? Why did it do this? So when Python evaluates this code, let me rephrase that. When it compiles this code, it says, oh, look, there's an assignment in there. Therefore, you're creating a local name. And it marks it as such. It says, oh, this function has a local. Okay? And then when we run the code, we try to reference that local name. Because for the whole function, because there's a name x that's local to that function, then when we try to access, this x here is going to refer to that local name in that function. Right? We didn't have to declare, it doesn't care about the ordering. And so that's why it says local variable x was referenced before assignment. So right here, this x is referring to a local variable x. And the reason that local variable x exists for the entire scope of the function is because I have an assignment here. Okay? So that surprises people when they see it, but that's why it does it. And you can see that the local x is gone after the function call is over and the x is still there. If you want to see behind the scenes how we can notice this, test 1 is, that one that scrolled off the screen, is a name which refers to a function object. The function object has an attribute which is func_code, and that object has an attribute which is co_var_names. Test 3 has the same thing, but it's got a local, right? So Python, this is where it keeps track of the fact that test 1 doesn't have any local variables, test 3 does. Okay? And it looks funny because it's a tuple of all the ones there might have been. Okay? So there is a global keyword in Python. How many of you have used the global keyword? Shame on you. Oh, no. Maybe there are good reasons why you might. Definitely good reasons why you might. Often it means there's a better way to code what you're trying to do, but not always. And here what's going to happen? What will test 4? X is 1. When I call test 4, what does global do here? It says, within this function, I want x to refer to the one outside, right? And so the fact that x equals 4 here is not going to change this internal reminder that it has that says, oh, I got to remember x is a local variable. It's not going to be a local variable. It's going to refer to the outside one. And so beforehand, it's going to show x equal 1. Then we're going to assign it to 4, and we'll be assigning the global one, the one outside, and it'll show the 4 afterwards. And now x is going to equal 4. Okay? And you can see that there are no local variables assigned on 4. I should have mentioned this back when we saw the error. Like here's the exact text in the tutorial, the Python.org's tutorial that explains the assignment to a local variable error we saw earlier. So I want to look at the local namespace briefly. I think that reminder to myself is incorrect. Yes, I misplaced that, sorry. I already showed it to you. Okay, local namespace. I'm going to restart it, and help. I'm going to call help on dir, and it says, if called without an argument, returns the names in the current scope. Okay, that's what we've been using it for. Else returns an alphabetized list of names comprising some of the attributes of the given objects and of attributes reachable from it. Okay, so dir is not just showing you the attributes, it's showing some of them, and it's also going up to get others from superclasses. Okay, so I've restarted my interpreter, so I've just got built-ins there, which you could ignore for now. And then because I'm actually running, there's some text in here that explains that I'm going to not use what is the current scope? Local, global, they're the same in the REPL. I'm going to use this for reasons that you don't need to worry about, but it's because I'm running Python from Python, so I can push the button. So if you do that, once I've done this, it'll work. If you do that, and I do this, then the following code will work for you too if you want to. I'm not going to explain this code in detail. I'm just going to show you. that, oh, I'm going to say, okay, mark exceptions, all right? And then I want to see all the built-ins. I want to look at what's built into Python and just learn a little bit about it using inspection here. And again, don't worry about understanding this code right now. You can look at it later and try it. That's not the point of what I'm doing here. So here are all the exceptions that are built in. So a whole bunch of the built-ins are exceptions that they're always available locally. And then all the ones that aren't exceptions, there's all those. And I'm going to split these into some smaller chunks. So here are a whole bunch of things that are built in that are types, because they're all type, right? And many of them you're familiar with. Some of them you might not be familiar with. And then there's a whole bunch of built-in function or method, right? And so here are all the built-in function or methods. So if we take away the exceptions and the built-in function or methods and the types, we still have some, which is interesting, eh? There's a few more in there. So there's a none, and there's quit and exit. Oh, there's none and under package. There's quit and exit, name and doc, help, a not implemented type, credits, license, copyright, true, false. So I have an exercise which I'm going to have you skip because there's more interesting stuff, but I would encourage you to do it later. So to explore exactly these pieces right here and sort of see, yeah, what's going on? How did Python do these things? So at this point, what I'd like you to do is on page 8, there's a set of exercises. I'd like you to do just the first lines 167 to 176. And the later ones we'll skip. So I'll give you just 2 or 3 minutes for this. And then we'll talk about it. Okay, we'll get started again. This one here, the underscore of type list, well, it just happens to be of type list. Underscore is a name in the interactive prompt. It's actually a Python interpreter, which is the last expression that was evaluated. I think that's roughly what its definition is. You rarely see it in code. You'll often see people who do a lot of code development in the interactive prompt. You know, they're like, okay, I need to take a string and uppercase it and split it at this level. And so they type in the code until they get it working, and then they copy and paste it to their code. And they'll use underscore if they forgot to save something, right? You type some expression, oh, wish I'd saved that. Well, it is there. It's always underscore. That's what that one's about. But let's look at the exercise, the first part that you did. Okay. Locals and globals are functions, or at least they act like functions, that will return something that's a lot like a list of the local names. In the Python interpreter, they currently have the same values, of course. They actually are the same. They return the same object that looks a lot like a list of the names. That's if you ran that inside a function, you would not see that true, right? If you were in a function, then globals would be all the global names, and locals would be the ones local to the function. All right, that's normal. I haven't defined X. That's normal. Okay, this thing that it returns is sort of like a dictionary. Oh, okay, don't do that. Bad idea. But the point is that you could conceivably do that. If you do it inside, there's something called fast locals. If you're curious, go read about fast locals in Python. I said this thing's like a dictionary. Well, it's not exactly a dictionary. And in locals, inside a function, there are some optimizations put in that make it really not exactly like a dictionary. Okay, I think that's as far as I wanted you to go on that one. Yes. Okay, so let's look at namespace changes again at the bottom of page 8. Remember, here are the things that modify namespace. One of the ones that you should become familiar with is import. So let's look at import and how it works. Oh, sorry, let me move along here. All right, so I'm going to slow down again and pretend you know nothing and use very precise language to try to help you understand exactly what's going on. When you say import preprint, import is a built-in keyword in Python that will try to look for a module somewhere on the search path in zip files or whatever the search path is defined to do, called pprint. It will evaluate it, create a module object that has a bunch of code and values in it, and then it will make a new name in your local namespace, right? Import is one of the ways you change local namespace, and that name will be pprint, and it will refer to that module as an object in memory. Okay? There it is. Huh, how exciting. And now I can refer to it, and instead of getting a name error, I will now be able to see, oh, it's module pprint from, and it tells me where I got it from. Okay. I can look at the contents of that module. In other words, at the more general way of saying is this pprint is a name which refers to an object. That object has some number of attributes, right? Well, here are the attributes of that object, which happen to be the contents of the module, the things that you're allowed to see in the module. It's not all the contents, actually. There are other things that are defined in that module that aren't exposed, but it's the one that, these are the attributes that the author of that module has made available to the user of the module. All right, so it's got pretty printer. It's got a bunch of dunder things, which we usually can ignore, and some single underscores as well. It's readable, it's recursive, p format, pprint, safe rep, or warnings. All right, okay. Let's just get rid of the ones that have the underscores. So here are the ones that, the common ones you might want to use. I can access those, and I get back the object, which is the function p format. And Python can't really display a function, so the representation it displays is it displays a bunch of text, just like it can't really display an integer. And integers, they don't exist. Well, they exist, but they're not. You can't touch them. So it displays text to show you it's an integer. Here it's showing you text to show you that it's a function. I can access preprint, pprint foo. Okay, it's not there, and I get a slightly different. This is a slightly different error than other attributes, but only right here, right? It's just an attribute error. It's not saying, oh, there's a module name error. It's an attribute error. right? Of course, it's not defined locally either. From pprint, import pprint as pprint preprint function. Whew. So the pprint, the prettyprint module has in it a prettyprint function, and I'm going to import it and give it this name locally. So that's another way to change the namespace. So just reach in there, grab me one of those things, and call it this when you get into my namespace. Okay? Now I can see it's right there. So the module, the function name, and I just said it's a function to remind myself. And what will that evaluate to? Ding, 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 ding. It is true, because they are the same. Those are two names referring to the same object, which is that function that I pulled, that is in that module object, the one I imported. And I imported it two ways. I imported the whole thing, and I imported part of it a different way. Right? pprint.pformat. If I get rid of pprint and import it as a module, right? So here's another way you can use import. You put as here, and it changes the name from the default. You can override the default name it's going to bring in. So now you've got the pprint module and the pprint module's preprint function. Say that 5 times fast. All right? So, makes sense? And the last thing here, with respect to imports generally, is you can, if you need to, you can call it as a function. Okay? And what I'm trying to show you here is that string module equals import module name. So import is a built-in function that you don't use very often. That's why it's dunder, dunder import. And you can give it a string, and it will go looking for that, use that string to go look for the module, and then you can do whatever you want with the return value. And one of the things you can do with it is just assign it. Well, that's sort of what the import statement does, right? And now I can access it like a local, it's a name in my namespace, and I can access one of its attributes, right? So string is the name of the module in the standard library. I haven't done anything with that, right? And the other thing you might not realize is that this will fail. And this will not fail, right? It's obvious once I show it to you, but the point is, import is kind of funny because you give import a name that doesn't exist, right? I say import space string. Usually Python says, oh, import, that's a keyword, I don't have to do with that. And then it says, oh, string. What name is that? Well, it's not a name yet, but import special, because it takes it and says, oh, I'll make it a name, going and looking for a module with the value of that name, the string, and go find it in the module path. Okay? So, a couple more things about importing, and then I'll let you play for a little bit. Let me show you here's a file structure that I have pre-created. I've got a folder 1, which contains file1.py. I've got another folder called module1, which contains a dunder init init.py, and a double underscore init double underscore .py, and it's an empty file. And in that folder, I also have file1.py, and it contains, got a weird line there, it contains attribute 1, which has the value 1. Okay? So you might want to keep that handy, because I can't show you both slides, but you might want to refer back to the top of page 10, which is what I just covered up. All right, restart, nothing there. All right? Import folder 1 doesn't work. Import folder 1.file1 doesn't work. Okay, import module 1 does work. So what's the difference between folder 1 and module 1? Yeah, what's that? Yeah, the dunder init file. So just by putting it in there, it makes it into a module. Okay, and I'm not going to go into depth about how this all works. I'm just pointing that out. And I can look at the directory, and you see module 1. And I can look at the contents of module 1. And interesting, it's got, like, the module object has a bunch of interesting stuff, right? It says the file where it got it, the package, name, the path where it found it, its a bunch of stuff like that. That works. And of course, that's no different. And here I can see the attribute in module1.file1. I can do that. Right? And once I've imported it, I can look at it directly as a name in my namespace. Okay? There's a lot more stuff behind here about modules and importing and stuff, and I'm not going to go into detail. I just wanted to give you a hint there. I do want you to go play a little bit with the other, with the exercise. Okay? So starting at line 219, I'll give you about 5 minutes, not even, maybe 3 minutes to go through those real quick just to understand stuff. And in general, when I say please go do exercises and I give you a list, we'll read them first, and if you know them, we'll go do something else. Or if you want to skip the first ones because they're obvious, but the second ones you're kind of curious, we'll go to those. So do whatever helps you learn the fastest. Okay. When I went around asking for if there were any questions, I got a comment, which is great. If you have a couple things. One is if you have questions for me, you can, of course, ask your neighbors. They're a great resource, too, and you might meet someone, get to know them. The other thing is the comment that if you have, when you use import, like here, for example, import pprint, I said this is not yet a name, and so Python doesn't treat it as such, but it requires it to be a valid Python identifier. So for example, if you're looking if you want to import a file that is inappropriately named with something like a space in it, and I mean inappropriately, like you shouldn't name Python files with a space in them, but you can get at it if you need to by using the dunder import. Okay? Obviously, the more common use case for the dunder import built-in function is when you don't know until runtime what module you want to import, and then so it's assigned to a variable that you got from somewhere else, and you import it that way. A couple other comments. Python 3, people are having trouble running reload. I didn't realize they got rid of that or changed it. Is anyone here getting reload to work in Python 3? Okay, so that's news to me. I hadn't noticed that in the stuff. I'm still using 2.7 most of the time. Just been playing with Python 3 a little bit. Okay, so let's just fly through this. Most of this is straightforward. You got to see things like what some of those values are. You can import everything from a module, and it imports all the stuff that the module's author has exposed for importing. And the PEP 8 and style guides say don't do that. But of course, if you're just writing code and playing in the prompt, at the prompt, well, go ahead and do it if it makes sense. It's a lot faster. It makes stuff easier to type, if not easier, and even though it's harder to read. The rationale for always do an import of the module and access the module attributes by name that's the rule of thumb. There are exceptions to that, places where you don't want to, is just to make your code readable. So someone sees, something dot something, they know where that function or attribute or class or whatever it is came from. And then the reload. So reload CSV isn't going to work because reload is a built-in function. CSV, it tries to look up that name and it says name error. It's not in my namespace, right? And I guess it's not going to work this way either because reload argument must be a module. It's telling us exactly what's failing here. I can import CSV, goes and grabs it from the standard library. And then I can say reload CSV, and it says, no, it has to be a module. It's telling me it's got to be a module. Okay, got it. I pass it an object, which is a module, and then it will go reload the contents of that file. So during development, you make a change to a file, and you import. Import doesn't go and check to see if the file has changed. It just assumes, I've got this imported already, I don't need to even go check, and that's for efficiency reasons primarily. Is there a question? He's saying he would have expected from pprint import star, the dir would have shown all the stuff, and it did, didn't it? Not the dunder ones, because those aren't ones that, right? Because when I said, from pprint import star imports all the functions and attributes, functions and objects, all the attributes of the pprint module that the author of the pprint module has made available for import. Right, so when you create a module, there's a dunder all attribute, and you can put in there, I think that's what it's called, a list of the string names that you want from whatever import star to actually give you. If I actually import the module and do a dir on it, it'll show me all the attributes. Okay, that's the difference. That's a good point. That wasn't very clear. I should make that more clear. Thank you for that question. Yep.
What's dunder package?
Didn't get anything like it didn't show you? Can't remember, did mine? Oops. There we go. Import preprint. There's the doc, there's the file, there's the name. I don't remember what package is used for. Who knows? At least 10% of you would know exactly what dunder package is used for. Come on. No. Don't know. Yes?
Did you have a module name as a string, or any way you could take that string and turn it into a module so you could pass it to reload?
Pass it to reload?
Pass the string in, but you can put the valid module in there.
So you have the name of a module as a string. Well, you need the module, though. You need the module object. How do you get the module object if you have a string? The way you... Right, so if you have a string, if I have a name which refers to a string and that string is a module, well, it's not a module. If it's the name of a module, I can use dunder import function, passing it that string, and what I get back is a module object that's been loaded, and then I can take the reference to that module object and pass that to reload, And reload will say, yep, you gave me a module object. I'll go check to see if it has been updated and needs to be reloaded. Okay, yeah.
Reload to the imp module in Python 3.
Thank you. Reload move to the imp module. Imp.reload. Thanks. Did you find what Dunder package is yet?
Yeah.
Great.
It finds any packages that are imported by that one.
It finds any packages that are imported by that module. Okay. Probably other questions. I'm going to move on, I think, because there's lots of other more interesting stuff. You'll have to go chase those ones down on your own. Functions. Oh, we're doing great. Let's look at some stuff about functions. All right. All I want to show you here briefly is here's a long, complicated function that does nothing, almost. I pass it arg1, arg2, keyword arg with the default value, and then star args and double star keyword args. Okay? So in Python, you can have a variable number of arguments. You can have some keyword arguments, some non-keyword arguments, and you can collect all the extra ones that are, depending on how they're called, in args and star star, whatever names you give these. And all I'm going to do here is I'm going to print them out, right? I'm going to show me what was passed in as one, two, as this one, all the other. Okay, so let's, before we talk about that, let's look at a couple of attributes of function which are kind of interesting. Yeah, f dot dunder name is f. There it is. I can change it if I want. Does that surprise anybody? All right. Def f is one of the ways to change a namespace. What it does is it creates a new name, f, in the local namespace and assigns it the function object that it gets from compiling this, right? And so here this refers to that function object that, again, I'm pointing up here, but it's actually something more complex in memory. And I can see that it's in my namespace. I can change the attribute of that function object, but I haven't changed my local namespace, so there's still f referring to that function object. If I check, well, it's there, right? I checked and see, and now you can see function g. So in that function object, I changed the name, right? But my local name for it is the same. And I might have another name. I might have, f and f1 and f2, all names referring to the same function object. The only time you would use this, we'll see a little bit later, or the only time you would typically use it. Func dict, that's kind of cool. Okay. You'll see this occasionally. There's a couple packages that use it. So a function, you can add attributes to a function on the fly, just whatever ones you want. Okay. And you can see what has been added in the func dict, and that's useful in some cases. Again, let me step back and say, I'm not saying you should go use all these things. I'm going to show you a lot of things today that you're not going to see again until 6 months from now. And you're like, what is that? Oh, I remember. I don't need to be scared or worried or surprised by this. It's part of what's going on. And it's part of the larger picture of Python exposes a lot of the internals to you so you can do interesting things. And usually you won't need to use them. And when you need them, you're like, oh, I'm glad I can actually do this in this case. Func defaults has some internal information about the function as well. So let's try calling that function. All right, no surprise. I got the two arguments. These two default arguments came through, and this is a tuple and a dict that are empty because I didn't pass enough arguments. All right. So you notice that arg1 and arg2, if I name them, I can reverse their order. arg2, arg1. arg2 is 1, arg1 is 2. Okay, so here the 3 overrode the third one. Check, reference back to your sheet if you're forgetting what the order of those was. All right, so here it left that one as the default, overrode the default for that one. Okay, there are things you can't do because Python can't read your mind, so it tells you. Here we can see these arguments got stuffed into the tuple, which is the collects all the ones that aren't claimed by any other declared parameter. And here we're going to stuff these two instead. Sorry, where'd they go? These two into that dictionary. right? So I'll let you play with these a little bit on the bottom of page 11. So I'll give you about 5 or 6 minutes to do the exercises, the second half of page 11, which then move over onto the top of page 12 as well. Okay, let me run through these exercises and explain a couple things you might not have caught. So here I just gave you an opportunity to try some of the things I was showing you so you could get them into your head a little bit tighter. Here I'm creating a tuple of 2 ints and assigning it to the name T, and you can see it's a tuple. And I'm creating a dictionary D. And now, sorry about that, if I call F and put a star in front of T, it means take T, dereference it, assume it's a tuple, a sequence actually, I think. It doesn't have to be a tuple. I'm not sure of that actually, I've never tried that. One of you will tell me soon. And it unpacks it into its 2 pieces. Yeah, it would be any kind of sequence, just like tuple assignment. And then passes them as separate arguments. Right? And if I call F star star D, then it's as though I said, well, I didn't give it 1 and 2, right? So it'll give me an error in that case. But if I say, no, pass 1 as arg1 and 2 as arg2, and then pass whatever's in D as though I passed kw1 equals 3 and kw2 equals 4 right in here. That's what the star star means. The star and the star star mean when you're calling a function. So you saw earlier, on the receiving end, it means collect arguments that haven't been otherwise named into either a dictionary if they were passed with the keyword in front of them, keyword argument, or as a tuple if they weren't. And here I'm doing sort of the opposite. I'm saying when I'm calling a function, if I have a tuple or some other sequence and I have a dictionary, I can sort of in place put them in instead of a number of function arguments. Okay? And of course I can do them both. So locals, whew, a lot of stuff in mine. I can say name equals dad, and 1 day shy of his birthday, I can say, hi dad, right? So I've got star locals is, so there are a couple things here to learn. One is locals return something that's like a dictionary. Star is going to treat it as though I called format with name equals dad, comma, f equals a function, comma, t equal, like a whole bunch of stuff. But in my format string, I only referenced one of those, so it gets it. Okay. I have used this in hack code that I was going to throw away an hour later. I don't want any of you using it anywhere else, but it's handy, right? When you guys, I just need to see it quick. Oh, throw star locals in. Again, you shouldn't be writing code like that, but I'm trying to stretch your understanding of the language and what's all there and what's available to it and what you can do if you feel like experimenting and playing and learning more about it. Okay? All right. Lists are immutable, strings are not. So S1 equals S2 equals hello. That's shorthand for making two names refer to the same object. That's what it does anyway. So I'm saying S1 refers to the string hello. S2 is another name that refers to the same string hello. And now I'm going to say S1. What this does is S1 plus space there. It's going to dereference S1, which is the string hello, concatenate it with space there, create a new string hello space there, and S1 is now going to refer to that. Right? S1, S2. Make sense? Now I'm going to use plus equals instead of plus. So you know what that is. I need to make sure I don't treat you like you're total newbies here. And no surprise. And some people say, well, you know, plus equals is syntactic sugar for the longer form. All right, let's do it with a list instead. Okay, that makes sense. Let's use plus equal instead. What's going on? All right. So again, I'm showing you stuff that you might be surprised by, and now we're going to try to understand it, and it'll make sense. All right. Why is there a 4 in M2? All right. Well, an equally legitimate question is why isn't it up here, right? And the answer is because plus equals is not just syntactic sugar. Let me show you what it actually is. So if I do m equals 1, 2, 3, a list, and then I do m plus equals 4, this is the code in the Python, this is the Python bytecode that the Python virtual machine is going to execute. And the one I want you to notice is right here. In place add. That's the actual operation that plus equals is calling. All right, if I do the same disassembly of the string, pretty similar, and there's the in-place add, it's the guilty culprit. Well, it's not guilty, actually. So when I said m plus equals the list 4, this is what behind the scenes happened. There is a dunder I add attribute of the list object that the name m refers to, and that attribute refers to the in-place add method of list, of the type list. And I'm passing that method this single argument, which is another list with a single value 4. Okay? Now, note the return value. Remember, I didn't mention this, but I think you probably all know that at the Python interactive prompt, or the REPL, the read eval print loop, if the expression that if whatever I execute has a value, then Python will display that value. Notice it has a value. So this this method returns a value, which is something that's kind of note. And you notice that what it returned is a list 1, 2, 3, 4. Okay? I think I have this one on the slide. Right. Same as on your handout, right? So the difference is because str's iadd method, the in-place add, copies, but the list types mutates it. And if you go look at the reference, it's very clear. These methods should attempt to do the operation in place, modifying self, and return the result, which could be, but does not have to be self, right? So list correctly does this. Why doesn't string correctly do this? Why does it not? Why did whoever wrote string, they didn't attempt to do an operation in place, or they tried and they failed? Strings are immutable. You can't, right? So here's some weird behavior. You might, if you run into it, I hope, will say, oh, okay, yeah, I get why that's different. Taught a class at my workplace. Well, some people, they see this and they're like, oh, that really is not, that doesn't make sense. What a lousy language design. I mean, any language that does string is immutable and int are immutable has some pluses and minuses, a lot more pluses than minuses, I think. But it's an interesting corner. It makes it easier to write readable code, would be my guess, but that's just my guess based on a user of Python. You'd have to go interview the people who wrote it and why did they give it an add function, an add method. Okay. Is Python pass by value or pass by reference? If you had that question coming in, I hope by now you don't have it anymore and you know the answer. All right? Because I've been brainwashing to think about how to read this, right? Oh, create me a new name in my local namespace and have it refer to a new string object which has hello in it, right? And then I'm going to dereference that name to be the hello object. I'm going to pass that hello object to test1. And in test1, there's going to be a new name, s, which refers to that object, right? It's all about references. It's just a name referring to an object. So up here, what's going to happen? Well, it's going to show me hello, and then s plus equals there. It's going to create a new string. In place add is going to create a new string, and s is going to now point to that new string, right? And s is a local variable, effectively, because I've declared it as a parameter, right? And what is str2 afterwards? Yeah, because str2 was always pointing at that hello string, and it didn't get changed by this code. It just got used, got consumed by those operations. Okay? Typo, sorry. All right. Similarly, a list of 3 elements. All right, what's going to happen? Object gets created, name refers to the object, name's dereferenced, the reference to the object, or you can think the object is passed, or the reference to the object is passed. Locally in here, that list is referenced by the name m. M refers to that. Beforehand, m is going to show up as 1, 2, 3. Then I'm going to actually do what here? What in place add tries to do for a list, which is change the object, do it in place. Right? And so that object that got passed in, or the reference got passed in, the actual object, that list, is going to get modified to have a new element 4 in it. You'll have 4 there. So we got 1, 2, 3, 1, 2, 3, 4. And list 3 now will refer to 1, 2, 3, 4. Okay? So lists are mutable. Strings are not. In place add has direction, how you're supposed to implement that. If you can, with string you can't do exactly what it says. Or it says do this if you can. Well, and otherwise if you can't, don't. And that's why the implementations are slightly different for string and list. And you can see that Python's always passed by reference. It's not that strings are passed by value and lists are passed by reference. They're always passed by reference. It's just what happens inside that's slightly different. Okay? All right. Get ready for your brain to hurt a little bit, some of you. If you're like me, at least. This kind of stuff, when I was first trying to figure out, I didn't quite get it. It was actually when I was writing this that I got decorators better. I haven't used them lots. I've hardly used them at all, a couple places. All right. Square, I've been defining as a function, takes a single parameter, multiplies it by itself, returns the value. All right, square of 2 is 4, square of 3 is 9. So I'm defining a new function called identity, which takes one parameter, which is a function, meaning it's a function object. In here, I declare a new function, which takes a single parameter, and when you call this function, it calls function on that parameter and returns it to the caller of this function. All right? And what is function? Well, it's whatever got passed in to my identity function. And when I call identity, the only thing it really does is it calls this function, right? So I've got two function declarations here. Two functions get defined, this one and this one. And the only thing this function does is call this one, but it's doing some funny things with names. So if I call str of 1, it will turn the 1 into a string by calling dunder str. If I ask the identity function to take the string function, what will it do? It will return a new function that takes a single parameter and calls the string function, and that thing gets returned. So identity open paren str close paren, that function call returns a new function, which I happen to happily call new function inside there. And if I take that function and call it with the parameter 1, it called str for me. Okay? Do I see more head scratching than usual? Maybe. This is a little bit harder to think about than traditional, typical programming. All right. Well, now let's, instead of calling it identity, I'm going to call str on. And instead of just returning whatever function got passed in called with a single parameter, I'm going to return the same thing, but pass it off to str first. So I'm going to call string on whatever function got passed in on, right? So this thing's going to return a function, and this is the same with some print statements, print functions actually, okay? So that's the only difference between these two. This is the clearing version, this is the one that is going to show us what it's doing. So look at this one, and you can say, well, for now, right? So call on str, you pass it a function, it's going to give you back a new function that's going to do the regular call, and then it's going to call str on it when it's done. All right? And here you can see I said called new function with whatever, and then called this function. So there's the two functions I'm defining, call str on and new function, and here I'm showing you each of those calls. All right, square. So when I called call str on, it defined this new function, and it did this, and it did this. And what we see is call str on, called. So this line got executed, and this got displayed, and it returned that new function. This did not get called. This print has not happened yet because I've not yet called new function, right? And now square str is that thing. Okay? So I said earlier, you might want to change a function's dunder name attribute. Here's a case where you might. When you're doing something like this, you might want this to have a more meaningful name than new function, something that changes depending on every time you call it, maybe it changes slightly. Maybe you let the user pass in, the caller pass in the name you want to call the new function, and it would show up in there. That'd be an example. Anyway, let's use this thing. All right. So a good way to think about this is where this thing refers, so square str, this function, where is this function? It's right up, well, again, conceptually it's this one right here. I added some prints, but it's the same one. If we ignore the prints, it's this one. Right? And it has built into it str right there. Sorry. Oh, no, it has built into it square. Sorry, I almost confused myself and you. So I passed this thing square, and now square inside here, it's the parameter with square was passed in, and square is going to get called, and then str is going to get called. So if I do square str of 3, now the function got called, and I get back, instead of 9, I get the string 9. Okay? Yep. You do, actually. You see one here and one here. Because the first time I only ran this code, and the second time I ran this code that was created by the running of the first time. Okay? And hang on while I make sure I'm not lost. If I drive carelessly here, you will all pay the price. All right. You've heard of decorators. How many of you have used them in production code? All right, so this is, how many have written them? Sorry, how many have written decorators? So this now, for those of you who didn't raise your hand, what's going on here is that at and then the name of a decorator, this refers to a function, right, which we declared up there, and it's going to call this function on this function and return it, and then, so cube, right, you see it got called. And now if I call cube2, right, the name that got this whole construct here, the name is cube, and it is this function passed to that function, and its function return value is assigned to the name cube. So that's the namespace changing we're doing. Question? It's not exactly, because it's what it's more like doing. So when it does this, this function definition happens, and then that function definition is passed as a function to this function, and when that function gets run, gets called, and you can see it got called, this function was passed in, and then that whole thing got assigned to the name cube. Oh, only use it if you have to. If there's clearer ways to write the code, go for it. Usually decorators, most people who are writing decorators are writing library code. I mean, there are cases when you're not, but it's usually, and not libraries for other people necessarily, internally. Very powerful, but yes, not without some costs. So when I call cube2, it calls cube. That's when that thing gets run, and we get the 8. Okay?
So it's not possible to undecorate.
It's not easy.
I mean, if you're using that concept.
Right. What would you mean by undecorate? Would you like to get cube, this definition back?
Yeah, the question was sort of the original name cube is now overwritten with
Yep.
wrapped
Yep.
the decorate function, so you can't access cube anymore.
So the function which has a single parameter n and executes this statement no longer has a name in our namespace. Yep. Which is I'm not.
So you can't undecorate to get the name back. It's one way out.
Right. And I'm answering it using my usual precise namespace language, because that's the best way to think about it. Now, can you actually go poking around somewhere in Python to get it back? Well, maybe. I haven't thought through that. Can you write a form of a decorator that lets you get it back? Absolutely, right? Or something that acts like a and when I say a form of a decorator, I don't see it necessarily as a function. It's something that can be called, right? Because I keep saying this function gets called. Well, I'm saying that because it is a function, but it could be something else that's callable. Okay.
So the act syntax is effectively what you sometimes call a compiler directive, right?
Some similarities. Yeah, we can chat more about that after. Okay, that's the end of my section on that. And now I'm going to twist and subvert the use of decorators to make you think hard about namespaces. So please go do the exercise. I'll give you about 5 or 8 minutes. Actually, let me rephrase that. Let me change that. It is 10:25. Our break's at 10:30. So go take your break now if you want to beat the rush, or take it afterwards. We will reconvene at 25 minutes from now. And by then, I would like you to have finished the exercise. So you can do it now or do it later. So either go now for 25 minutes or go in 5 minutes for 20 minutes. Hang on. So during the break, someone asked me a question, could I do something like this and swallow some of the arguments? And so I just, here's how you would, right? Is instead of passing, I passed a second argument here, and then instead of calling str on it with a function n, I just called it with the argument right away. Right? So that's roughly how you do it. The very last page, if we get there, will also show you a couple other ways to do that. For example, partial functools standard library module called partial that does that kind of thing. Okay, let's go through this weird example, this weird exercise I gave you. Which, as I said, is a misuse of decorator, but it might help you think about what exactly is going on with namespaces, right? It sort of bears it down. This is all that decorators are doing. Okay, so call is a function that takes a function and calls it and returns the value. So it doesn't do much, right? And x is not yet defined. Int. So if I call int with no arguments, I get back 0. I just happen to know that. Comes in handy some places. If I call on int, then int, which can be called, it's a type, but it can be called like a function. Sorry, it can be called like a function. It's going to have, the name f in here is going to reference that thing that can be called. I will call it, remember its value momentarily, and then return it to the caller. So I get, oh, what happened there? Any idea? Well, I didn't do what I just described. I was calling it with 0, right? Okay, so call int will do what I want, though. If I call int, it's as though I took that function and called it. All right. What will that do? So what happens here is Python sees the @call and says, oh, let me go look up that name. Found it. I'm ready to use it. It then evaluates this def all the way to the end of the block, creates a new function object. That function object will have internally a name x, but it's going to get, that's only internally that happens. It thinks it's x. And that function, all it does is returns 3. It then takes this function object, the function object that it creates from this code, passes it to call. Call evaluates that function, meaning it actually calls it x with no arguments, gets back a 3, returns a 3, and that return value 3 is what gets the name x. So the name x now refers to the int 3. Right? So again, you would this would be a silly way. This is not a helpful. My point here is not this is a really helpful decorator. It's not a really helpful decorator. This is a weird decorator to try to make sure you're understanding. Here's exactly what's going on with decorators. This is all they're doing, and this is just about namespaces, right? So this is all namespace stuff, right? Usually def x creates a new name in our local namespace called x, which is this function. But if you put an @call in front of it, it instead puts in the result of calling that call function on the object in the local namespace with the name x, right? So x did not exist earlier, and down here x does exist. And what it is this function passed to that function, and that function actually evaluated and got the 3. And whatever call returned when it was passed x. It's that simple, okay? Thanks to Lefkowitz, who he had a talk in 2010 called Turtles All the Way Down. Great talk, which inspired some of this, the way I'm presenting this, which is online. Okay, I got one more little piece in here. Oh, right. Okay, so the other little piece is, if I wanted to show you how you do it without decorator, just to make sure you understand, right? X doesn't exist. Here, that should be returned 3 to be equivalent. X is a function, x equals call x. Conceptually, that's what happened when we decorated x with the call decorator. Okay? Unfortunately, that's all you get for decorators, because we're talking mostly about namespaces. But this is the foundation. Once you know this, then you can go read decorator stuff. And some of you, when you went and said, wow, I still don't get this, hopefully this will help you go back and go, oh, okay, now I have the tools to get it. So, on to the class statement. Classes. I'm not going to answer this. So not why are we talking about classes, but how are we talking about classes? Well, in case you haven't figured out, we're going to talk about it with respect to from the perspective of what does it do to a namespace and how does it work, for starters. Okay, so everything is Python is an object, all that kind of stuff. Many objects are instances of classes. I'll just leave it at that. The type of such an object is its class. Classes are instances of metaclasses. So the type of a class is its metaclass, right? Trick question, well, not a trick question, obvious question. Are classes and metaclasses objects? Yes. Are apples objects in Python? Yes. Everything's an object in Python, so obviously. So the class statement starts a block of code, and it creates a new namespace. And all the namespace assignment operations that happen in there, which are, right, you know what they are, almost all of them, happen in that new namespace, and then it creates, the name of the class gets put into our current namespace with all of those attributes hung off of it. Okay? This is the way you call a class. You just give its name and pass it some number of parameters, 0 or more. Its dunder init method. Its dunder init method is called with this object that's passed in. It actually was created before it got there by new. Some of you, dunder init is not a constructor in the sense of it creates the object. Python creates it for you. Dunder init initializes it. And then when you access an attribute method name on a class instance, it returns a method object. If it references a method, that is. So if you reference something that's not a method, it won't return you a method object. And a method object binds the class instance as the first parameter to the method. Okay. Let me show you this is true. So I'm going to show you a bunch of, again, weird stuff here that you shouldn't do in code, but it'll help us understand how Python does it and help you understand code, I hope. So I've got this number class. I put in these comments here because just because I'm running in the interpreter prompt, it's kind of in case you were curious. So I've got an attribute. I've got another attribute, which this attribute is a reference to a string. This attribute is a reference to a function with 2 arguments, which does this with them. And this function is another attribute of this, which does something. Okay, so it's a number, and you can create it, and you can add it. Yeah, I noted that. So number, class number. So number is now a name in my local namespace because of this class statement. And it knows, all by the way, that its name is number 2. I can call it something else later in the local namespace, but it thinks its name is number. And I can access an attribute like version, and I get back a string. I can access its doc, which gives you that attribute that got stuck in there. I can call help, and it does interesting things, and I have to go find my Q key. I can access dunder init, and if you were listening carefully or already know what that other slide said, then what's this going to do? Unbound method number dunder init. Sorry, that was misleading. I didn't talk about what this does in the slide. This just does what you'd think it does. It just accesses an attribute of that namespace, as does this. It's just saying it's a function up there, but it calls it an unbound method. So it's being smart about the fact that it's not just a function. Because it's in a class, it's doing something a little different. And it's got a bunch of stuff that it imported from object. The two that we defined, of course, are dunder init and add. All right, let's create a number, an instance of the class. And we see, you have to go back to your sheet if you want to remember, the dunder init took whatever we passed to it, and the call of the class created the object and then called dunder init with the same argument. 2 of them, actually. The first argument passed to dunder init was the instance that Python created. The second was the number 2. All right, and it stored that in self.amount, and so I can access self.amount. Okay, number object, number.init unbound method, number.init bound method. So it's a slightly different thing when I access the dunder init method from the object versus from the class directly. It's returning a different thing. Same for number add, right? They're both bound methods. And what that means is the first argument is going to be whatever number refers to is being bound as an argument to add, right? Sort of like we did with the decorator stuff. That wasn't really decorator stuff. It was just functions returning functions. And there's a lot more of that on the very last page of your handout, last 2 pages. And it's got a bunch of stuff, right? So the instance, here's what the class had, here's what the instance has. They're pretty much the same, except there's an amount in the instance that there wasn't in the class. There's a dict that says here's what the local attribute of that instance is, which is different than this dict proxy thing. Don't worry about that. Okay. So this is going to call the capital numbers add method and give me a 5. All right. Can I do this? If you look at the definition of add, it is a function, and it has how many arguments? Right. Must be called. So this function, well, okay, this unbound method must be called with number instance as its first argument. It got an int instead. So this is not the way. You can't call regular methods of an instance on the class. It'll fail. We're not looking at static methods here, or class methods, I mean. Can I do this? Right. Can I do this? Yeah, that'll work, right? This is not the right way to call, but this is, you can do this. You can say, oh, I just want to go get that function thing, which when I get it comes back as an unbound method add, and I can say, well, here's the instance I will work on that's going to get called self inside that add method, and here's the second parameter I want to pass it, and it does the right thing. Here's the right way to do it though, right? And here's the binding. This number 2 gets bound as the first argument, and the 3 gets to be the second argument of add. Yep. I don't know. Good question. You'll answer soon, right? You'll go find out, or somebody will. All right, so now let's get a little more dangerous here. I talked to someone yesterday who said, from a well-known company, that they were in this class last year. I said, what did you learn? I said, well, for example, that stuff where you can do this. And I said, yeah, but you're not using that, right? He said, well, actually, we are. There are rare cases when you might have to do this. Don't. The general is you should never do this. If you get through the rest of your career with never doing something like this, I'll be happy. Doing what? Well, let me show you. All right, so set double amount looks a lot like the init method. Takes a self, takes an amount, changes self, adds a new attribute, amount, to self, or if it's already there, changes its value to be a reference to double the amount. That's why it's called set double amount. Number init is this unbound method number, and it's blah, blah, blah. Let's just overwrite it. Let's just go take the class and say, nope, make this your init method instead. Okay? Don't do this. All right? And now I can ask, what is it? And it says, well, instead of saying it's an unbound method number init, it's an unbound method number set double amount. Well, sure, I'm just wiring it up there, and I can do help on it, and it says it's whatever I put in there. Okay. So now my theory is that when I call number with the number 2, it's going to call set double amount, double it, and I should get back the number 4. And if I add 5 to that, I should get 9. So it works. Okay, so this is how Python is doing the behind-the-scenes wiring for classes. And other languages do it the same way. They just don't expose these things at runtime. Not all, some of them don't. Or not all of them do. All right. So number 2.init, what's that going to look for? Is that going to be the old init or the new one? It's going to be the new one, because number 2 never had an init. There was never a dunder init on number 2. There was only a dunder init on number 2 superclass. When you try to get number 2.init, it looks and it can't find it. It goes to the superclass. Ah, there it is. Right? And it finds the one for the class. Right? Because it would be inefficient to have every instance of a class have all the stuff that belongs up in the class. That's why we have the reference up to the class for them all. Okay? All right, let's add multiply by. Whew, this is getting to be a very complicated feature, well-featured, full-featured class. It can now do initialization, adding, and multiplication. And let's do a mistake. I want to add the mul method. This function, I want to make a new mul method. And so I'm going to just assign it like I did last time, right? Hey, there it is, but it looks different. It's not an unbound method. It's not a bound method. It's a function. All right? So when I try to access the mul attribute on this instance of the number class, as Python goes looking for it, depending on where it finds it, it might give you something different, right? If it finds it in the instance, it thinks it's a function. And it acts just like a function, right? It takes 2 arguments, num and value, and I only passed it 1, which was 5, right? So it's not a method. It's just a function that I happen to hang off an instance of one of the instances of the class number. Will this work? Now, the only thing you need to answer that, no, the only thing you need to do to answer that question is look at the definition of the function and see if the arguments I pass it, is it actually going to execute this code without causing any problems, right? Does number 4 have an amount attribute? And is there a second parameter? And can I return it? I can do all those things, right? So I'm just calling a function here. It's just a function that has to have, it's a function that assumes the first parameter has an attribute called amount, right? And the only reason it does is because dunder init made it so. Number 4 mul, number 10 mul. What's the difference here? I never changed the number class. I only changed the number 4 instance to give it a new function hung off of it, give it a new function, to just give it a new attribute which refers to a new function. So when I go create a new instance of number, it has no way of knowing that its sibling got this extra piece, right? And it goes and looks for it and says, can't find it anywhere. No such attribute. And you can see that number 4 has amount and mul, and number doesn't have either, right? Doesn't have amount because it's not an instance, so dunder init never got called on the number class. It only got called in the instance, and it doesn't have mul because it's not there. All right, so let's put it in there. Let's add to the class number. Let's add the mul attribute, which is the multiply function, a reference to the multiply function. Now this will work, right? No. Why is that? Because now the number 4 object and the number 10 object both are subclasses, or instances of the number class, and the number class has the mole method, but the number 4 instance still has this mole function sitting there. And so when it started looking, so yeah, I've got an attribute called mole4, and it's a multiply function, and it's got the wrong number of arguments. Whereas if I call number 10.mole5, will that work? Yeah, because it'll go, it looks locally, can't find it on the instance, goes up to the class, finds it, returns it to the caller, me. This whole thing here is now going to be a bound attribute, and everything works. All right? So number 4's got a mole, and it's a function. So let's get rid of that. And number mole, we're okay, it's unbound. Number 4 mole, we're okay, it's the same thing, right? So the multiply function that I declared up there, I created up there, and I just stuck into the number class right up here. See, so now I'm going to access the same chunk of code 2 different ways, one via the class, one via the instance, and I get back different things, which we saw earlier. But I'm coming around to repeat it so it sinks in, I hope. So now this will work.
Something that threw me, but I figured out what it was, is that in the double, we use self as the first parameter, but in the multiply by we use none, but they're both being used identically.
That's right. Yep. So the parameter self is convention, not required by the language. Follow the convention, please. Yeah. Yeah, I could look at their attributes or something like that. And there's very rare cases where you would expect one instance to have other attributes, a different set of attributes. Like usually all instances of a class are going to have the same attribute. That they should. You know, it'd be weird not to. I'm sure there's some reason somewhere someone said, I really need this weirdness, but I'm not sure. And there probably was a better way to do it. Okay, so we're going to the land of Oz here, and I'm the wizard, and I'm going to show you what's behind the curtain. So number 4 is a number object. Oh, that's interesting. It's a number object, so it knows about its class, and this is how Python tells us what it is. It's an object. It's an instance of the number class, and it's at a particular memory location. Right. So what does a bound method have? A bound method has, well, that's interesting. It's got a dunder call, which means you can call it. So even if it's not a function, you can still call it. Even if it's not a function, you can still call it. So it's got a bunch of other stuff. Anything interesting? Oh, it's got a dunder func. That looks suspicious. It's got a dunder self. That's kind of interesting. It's got an im class, im func, and im self. All right. Okay. And you may, I think there are a couple differences here between Python 2 and Python 3, some of which I've noted, but I may have missed some. Hey, look at that. Look at that. Number 4, number object. Number 4's mole bound methods self is a reference to the same thing. So that's where it does the binding. So behind the scenes, that's what the bound method is, some kind of object that, of course, it's all their object, and it's got a dunder self method, a dunder self attribute, which actually is, that's where the binding is, right? And they are the same thing, yep. And by the way, dunder self and im underscore self are the same. Hey, what's that? What's this one? It's got this dunder func. Well, there's the function. That's where it's squirreled away the function for later reuse. And they're the same thing. They are the same function. And dunder func and im func happen to be the same. New style and old style naming. I don't know the history of the name change there. Yeah, yeah. Okay. Im func is a func. The dunder class is of type instance. So the dunder class of number 4.mol is an instance method. All right. So when I do number 4 mol5, it's as though I did that. Right? It's as though I called that function with the instance that was bound in that bound method and passed it a number parameter. Passed it the 5. So here's how Python keeps track of the actual binding of that stuff. Now, whether it actually executes that way, I don't know. I haven't gone look anywhere else. I expect it does, but I don't know. Okay. Weird, eh? Was that fun? Did you learn something? Some of you, hopefully. So, see if you can. I've got a long exercise for my length of exercise in a short 3-hour tutorial, which is at the bottom of page 17. Go try to do this yourself in a similar way. So I'll give you about 8 minutes for this one. Okay, I'm going to hurry you along. Most of you did not finish that. I can show you the solution afterwards, but basically the solution is you would need to create a function that looks a lot like a dunder init function would have if you'd written it the right way, and just say prefixer dot dunder init equals that function, and things should start working. Okay? Let's look at one other interesting thing about classes and types here. So the class statement, this is from Glyph's talk in 2010. It's just a way to call a function, take the result, and put it into a namespace. We got that. Turns out that there's that the type function, where we've seen a few times here, you can actually pass it multiple arguments. If you pass it 3 arguments, it will do the same kind of thing. And again, not that you will, I've never used it this way, but except for playing around. Right, so if you look at type, it actually says, well, there's 2 ways to call it. So there's the init that I did earlier for the number class. There's the set double amount. This is just repeating what you saw earlier, so it's on the screen. So I can do this instead if I want, and I get the same effect as what I did earlier, right? Is except I changed the class name from number to double num. So I say, let's give me a local namespace entry, a name in my local namespace, double num, and make it whatever this thing returns. And what this thing will return is a type, which is a class, which it thinks its name is double num, and its subclass, its superclass is object, and no others, and it's got these attributes. It's got a dunder init, which is whatever that function thing is, and it's got a mul, which is whatever that function thing is, which that one I didn't give you. Sorry, I should have repeated that too. Right? So, and it works the same way. Right? So, just so you know, you can do that if you want to. I don't think you'll want to unless you're writing meta classes and complicated libraries. Yes?
By mistake, I did that once.
Yeah?
And called that type on thousands of class instances. And what it does is loot your local namespace, because all those local variables are still hanging around even after you created the class.
Interesting. So he said if you call that on, you by mistake called that on many instances, and it polluted your local namespace. I'm not sure how exactly that happened, but interesting. Yeah, so you probably won't use this, but just so you know, that's what's actually going on. Okay, so now there's this other piece, meta class. When the class definition is read, if meta class is defined, in other words, if there's an attribute meta class, then the object it references will be called instead of the type function. So you've heard about meta classes. How many of you have actually written stuff with meta class? Not very many. I did not raise my hand. I haven't had a need for it. I'm very grateful for all the people who know how to do that very well and write great libraries that we can use. And meta class can be any callable accepting arguments for name, basis, and dict. All right, so that's how meta class as an attribute works. Let me show you instead of letting you play with it. And I'm going to show you, I'm going to be bad again and show you the wrong way to use meta class. Just so you understand this is exactly what's going, that this is all it does, right? So I'm going to create a function, which if you remember what was on that slide or you look in your handout, looks a lot like type. Why? Well, because it's a function and it has 3 arguments. I just happen to call it name, bases, and adders because I wanted it to really, for you to really look like type. Of course, the names I give it, these names don't, none of these names matter. It's just a function with 3 arguments. And it's supposed to return a class that, class, lots of stuff, right? I'm just going to return an int, the int 1. So if I call it with the right number of arguments, no matter what they are, it returns an int. Okay. If I'm running 2.7 and I create a class X, which is an instance of, which is a subclass of object, and I define this attribute to be a reference, it refers to this function I declared, then according to what that slide said, when I create instances of the class X, metaclass is defined, the object it references will be called instead of type. Okay? So it's not just that you can call type behind the scenes, it's not just you can call type instead of writing a class statement, it's that Python calls type behind the scenes. It's actually using that type function. And all you do is wire in metaclass and it'll call that instead. Okay? If you're running Python 3.x, you would do that instead, I believe, based on my little tests. So the syntax changed slightly. I don't know if dunder metaclass is supported still in Python 3 or if I'm not sure. And this is, yeah, it's just complaining. Okay. So X is 1. I think I have a mistake here. Oh, no, I don't. This is exactly what I wanted. Sorry, I was getting confused about instances and classes, right? So what the slide said is when the class definition of red, if metaclass is defined, the object it references will be called instead of type to create the class, right? So normally a class, what happens is your local namespace usually gets the name of the class and it's got a lot of stuff in it. Instead, it got all that stuff not from the type function that's built in that it should have called or usually would have called. It instead got it from my overriding of the type function basically, which is just it called that thing and it got back a 1 and there's a 1, right? So if you're looking to win the obfuscated Python code contest to see how can you make a local name X refer to the int 1, this would be a good start, right? But so the lesson here is Python exposes, like it's got this built-in type function, anyone can call it. If you can not override it, but create one that acts just like it, put it as your meta class of your class, and it won't use the usual type. It'll use this instead. Okay? So I'm not telling you how to use meta classes. I'm not telling you anything. I'm talking mostly, again, about namespaces. I want to show you another example. What's this? Oh, right. Sorry, I forgot this was coming because it's in the exercise section that I'm doing for you instead of letting you do it because we're right on track to get all the good stuff in, skipping a couple sections that are not quite as good. No surprise there, right? Don't get confused by the names. I declared a function which takes a single parameter, ignores it, and returns the number 2. So I pass it a parameter, doesn't matter what, it's going to ignore it, it's going to return the number 2. Right? So we saw what decorators do, not how you can use them and write good ones, just what they do on a function. This is what they do at this level of namespaces and calls on a class. Okay, so you get what's going on? In this case, if you decorate a class, what happened was the, get it? Yeah, this is the class decorator, not a function decorator. Same syntax, but this one's before class. And you see that all that happened was class Y, instance of object. Well, this whole thing, what happened was this, it's just like the meta class, right? There may be subtle differences, I'm not aware, but effectively it called that and said, oh, okay, we'll call that to create your class. Here's the class, except all we did was we just gave it a 2. So here's entry number 2 for the obfuscated Python. And these aren't my examples, I actually stole them. They're good ones. Again, just think about namespaces. So now you sort of know, oh yeah, if I want to go learn about meta classes or about class decorators, it's as simple as that, which is not necessarily terribly simple, but it's at this end, it's pretty simple. Okay. I want to show you briefly, talk about a little bit the standard class methods. And these are all documented in the standard library. Go read about them if you're curious. We've seen some of these and some we haven't. Some of them you're familiar with. The dunder new method is one that, anyone here ever written a dunder new method for a class? Yeah, I'd done it once myself a couple years ago, and needed some function, something about float. I can't even remember exactly what it was. So uncommon. These ones we're going to see a little bit later. Del adder call I've mentioned in passing dir. Interesting. So you can override what dir returns. Len you can override. All these things have to do with looking inside sequence. Then there's a whole bunch of math stuff, right, that you can override. And there's two forms of many of them. There's sorry, hold that thought. And then there's some interesting ones that, you know, turn things to int for having to do with coercion. There's all these R add, R sub, R mul, which is if you try to call, if you use plus on an object, it'll go look for the dunder add method on the object and pass it the right-hand side as its parameter. If it can't find it, it'll go look on the other one for the radd method, so you don't have to duplicate as much. You don't have to write the same code twice. Enter, exit, next. These are used for context managers, and this is used for in Python 3. I can't remember if they put that in 2.7. Anyway, it has to do with iterators, which we're going to look at briefly as well. Very soon, in fact. So, the bottom of page 20, the exercise, I'm not going to give you time to do right now. It's fairly straightforward, and sort of lets you see learn a few things. The properties section in the middle of page 21, I'm not going to do right now. It's also fairly straightforward. It just shows you how you can set up properties ahead of time. After the fact. Typically you would, write your classes, make your attributes accessible to anyone, and if later you need to control them better, well, you can add properties and your client code doesn't need to change. What I am going to cover now is iterators. So an iterator is what a for loop evaluates an expression to get an iterable. Here's how for loops work in Python. You evaluate expression, you get back something that can be iterated over. It's iterable. It calls iter on that thing that can be iterated over to get an iterator, and then it calls that object's next method over and over and over until it gets a stop iteration raised by that, whatever that iterator object is. And when it gets the stop iteration, it exits the for loop without, it catches that and exits the for loop. What the iter function does is it checks to see if there's a dunder iter method and calls it if it exists. Otherwise, it checks to see if there's a get item method. If there is, then it calls it starting at 0 and just starts marching through. And when it gets an index error, it returns a stop iteration. That's the core of the iterator protocol. Why do you care? Well, I'll give you some examples. Sorry, this is just to remind me. Somebody remind me in about half an hour that there's a survey that I want to show you. I think I will remember to do that. I made a note later as well. Oh, let's skip these, like I said. I'm not going to go through this, but roughly, here's the pseudocode for what I put on the last slide, if that helps. Helps you understand it. Okay. My list. It's got this little class. It takes a sequence, saves it in items, and I'm going to override get item, so it actually tells me that it called it, and then it's going to return that one. So I'm just creating this simple class. Okay. Right? It's fairly straightforward. If I call that method, passing it as 0, it's going to tell me it did that, and it's going to return the 0th element. So it's going to return the A. If I call it on 1, it returns a B. Call it on 2, it returns a C. 3, it returns an index error, right? Because when I tried to get it back here, this thing raised an index error, and I see it. Okay? And attribute access uses get item. Okay? Does M have a dunder iter? No. Does it have a get item? Yes. So, if I call iter, it's going to check if iter exists, and if it doesn't, it's going to check if getItem exists, and it's going to call it. All right, let's see it do that. Right? So the iter is like, why is it checking for dunder iter and checking for getItem? Well, because then sequences are just automatically, anything that acts like a sequence, meaning it's got a getItem, whether it's from defined in the core library or the standard library, or you defined it, it understands the iterator protocol without having to go define dunder iter. And what's going to happen here? What am I going to get back? What's that? I won't get index error. Why won't I? Because it'll handle the index error and it'll raise a stop iteration to turn it into the iterator protocol, right? And if I call list m, right, just create a list from this iterable, yep, goes and does all those things, of which we can sort of see the 4 here, including the one that failed, right? It called it that 4th time. Of course, here's usually the way you would call it, right? You just say for item in M, print item, and that's why it prints A and then B and then C. Okay? What's that? Yes. Yes, exactly. Like, where did the 0, 1, 2, and 3 come from? And the answer is they came from the iter function that looked for a dunder iter method, couldn't find it, said, oh, but you've got to get getItem method, so I'm going to call it starting at 0, then 1, then 2, then 3, catch the index error, return a stop iteration. The for loop says stop iteration, I'll exit the loop. Those are the 2 layers. Okay? And here, hang on. So the second half, basically everything in page 23. Sorry, I'm trying to skip this. I'm going to skip past the stuff on the rest of page 23 because there's other more fun stuff I want to get to. Yes? Yep. Yes. To do something else? Yeah, make your own getItem. That's exactly what I did. Because I defined the getItem method in the class, then when, as a user of that class, of an instance of that class, I said m square bracket 0 square bracket, then my getItem method got called with the parameter 0. Yep. So, page 24 at the top, there's a little exercise with iterators, and I'm not going to let you finish this one either because we got some other cool stuff. So if you could do, I'm going to give you a few minutes to do on page 24 through line 517, and if you still have time, skip down to line 528. So stop at 17, skip down to 28, 517, and then skip down to 528. And I'll give you about 3-4 minutes for this, just to play a little bit and take a break from hearing me. Okay. Yes, question?
We can modify the indexes and the iterators of each item. Is it possible to make something akin to like a decorator that can add a skip list to an iterator so it can, you know, for like searching through something quicker going through there? Or what happens if you take the index and modify it in such ways that it always loops back to the beginning at the end? So is it possible to do that?
It is, so is it possible to modify the index? Basically, a bunch of interesting questions of things you might be able, you can do. My suggestion is go look at the itertools module. It's probably already written for you. Then go look at the implementation of the itertools module to learn sort of how you can, modify indexes to skip past things, etc. Yeah, and we can talk further after. I'll be around afterwards if you have specific questions. But just sort of a general tool, a general advice is I'd say go start poke around in there for starters. Okay. Any questions as you went through the exercise here? As far as you got before I called halt? Okay. Hang on here. Exercises. Iterators. Okay, this first half of page 25, I'm going to go a little bit quick. So I'm going to create a new class, and I'm going to create an instance of it. And I get back a generator object iter. Okay, that's interesting. I'm going to define a myGetItem, which similar to the dunder get item I defined earlier, but I'm going to use that hack we were doing earlier just for fun. Not sure that's a good pedagogical device, but too late now. So you notice that I say my get item self key. I actually ignored it, and I just only look at the key. So I'm basically assuming it's this data I want to return. I'm going to wire that thing in, generator object 0, 1, 2, 3, 0, 1, 2. Okay, that works. Oh, that's interesting, right? So I've got this. I did some wiring with my get item similar to what I did before. If I call 1 in my IT, is it in there? This is how it does it, right? So the in operator uses the iterator protocol, which is going to go look for dunder iter, not find it, go look for get item, find it, and it just works. All right? Happens there too, right? The iterator protocol through the dunder get item method that iter looks for, if it can't find dunder iter, is getting called when you do tuple assignment, right? I want to assign X to be the first item, Y the second, Z the third, and then we run out. And of course, it makes sure you run out so it has the right number, because it wants to warn you if you tried to assign 4 things to 3. So it actually goes right to the end. It doesn't just stop at 3. Okay? Okay. So that one, it's doing the same kind of thing, but I didn't. It's part of why I'm skipping that is because I don't think that's as clear as it should have been. Here's an interesting one, and this is what I want to focus on for this section. So that first part, don't worry if it wasn't clear what I was trying to get across. It was not as clear as it should have been. So I'm going to create I want to use the iterator protocol this way. Meaning I want, when someone tries to iterate through an instance of this class, and that happens like in a for loop, or when you call list, or when you call in, or any of those ways, or tuple assignment, I'm going to provide it a dunder iter. Okay? So what dunder iter, if you're writing a dunder iter, how many have written a dunder iter for a class? A few of us. What you have to do is you have to keep track of the state. Where are we? And you have to handle either the next in Python 2 or the dunder next in Python 3. You have to handle calls to that method, right? And so the way we're going to handle them is when dunder iter is called, because an iterable, because iter looks for it and calls it, I'm going to remember, okay, I'm going to start at 0, And then every time next is called, I'm going to check to make sure I'm within the first 3, just because this is a list of 3. Okay, this is a really kind of made-up example. But the point is, this is what I'm going to do, is if the index is less than 3, I'm going to increment it and return self.index. Okay, well, self is going to be whatever got passed in. We'll use this, and you'll see what it... Okay. So what happened here? So I'm going to return self.index, and then I'm going to raise stop iteration if it's not. Okay. So the first time through, and then the next, returning self is very important. I should have explained that, sorry. So if you want to define your own dunder iter method to implement the iterator protocol on a class that you're writing, then you want to define dunder iter, and the convention is, you don't have to do it this way, but typically you would just define dunder next, or next, depending on which version of Python you're running, in the class itself, and then you just return, all you're required to do is return an object that has a next. Well, here's the simple way to do it, is just have the class itself have the next method, and then return self, because it'll be an instance of an object that has the next method. Okay? And the other thing you have to be careful with is the definition of the iterator protocol is every time you call next, even if it's already been exhausted, even if the iterable, the iterator is already exhausted, you should still raise stop iteration. If you don't do that, things can break. Okay, so those are the rules for defining, creating an iterable class, a class whose instances are iterable. So, the exercises on iterators, I'm going to give you a few minutes to work on that at the top of page 26. Okay, I have to confess something. I told you I'd give you 5 or 10 minutes. I actually intended to stop you right about now. But I wanted you to think you had 10 minutes to go solve this problem. And my purpose was, in 3 minutes, I wanted you to think, how would you solve this problem? Right? And the reason I said don't use yield is because it's just too easy with yield. Right? So if you want to solve this problem, then you would want to define your own class. Superclass would be dict, so you'd be subclassing it. And you would want to define a dunder-iter method, which would set up some initial state, and then it would return self, and then you would define a next method that would use that state, and each time the next method was called, it would give the next item back, where the next item in this case is in sorted order, right? So what state would you need to set up in the dunder-iter method? Well, you'd need to get the keys and put them in sorted order or something, or create something that will do that for you lazily. And then every time next is called, you'd say, oh, pull the next thing out. Like the easy way would just be, go ahead and create a sorted list and remember it. And then every time next was called, you'd say, oh, okay, return the next one, return the next one. Like every time through, return this one, next, and update the state. Next time through, return this one, update the state. And when you get to the end of that list, and you could just, if you just stored a list, you could, catch an index error and return a stop iteration, raise a stop iteration. Or if you have, you're evaluating lazily, there might be a better way. But the point is, that's the way you would think about it, is you say, okay, I need the dunder-iter method that sets up the state, returns self typically, and I need the next method, or dunder-next method, which actually doles it out one at a time every time it gets called, and returns, raises stop iteration. Okay? Sorry for tricking you. It was the best way, I thought, to get you to think that much about it. We're getting close to the end. We've got 25 minutes and 2 or 3 interesting sections to cover. So page 26, all the stuff on generators, it's there for your, to look at later if you don't, and how they relate to how they relate to the iterator protocol. I did want to show you briefly, starting at 581, this code. Let's try that again. There we go. My little runner got confused. So in case you haven't used generators, if you're not using generators as part of your regular toolkit, make it part of your regular toolkit. And here's a quick little example that shows you why. Which one's easier to read? Which one's clearer to think about? I mean, they're both trivial, so they're both pretty easy. But your quick answer's got to be the short one, right? Obviously, it's more efficient for a bunch of reasons. David Beasley had a great talk a couple years ago about where he tried to duplicate a bunch of the Unix piping commands like grep using generators, and the performance was actually just as good, and it's a different way of composing these operations together. And of course, the way you call them, in this case, in a list comprehension, is the same, right? You put in a for loop, and it just gives you the stuff you need, right? But instead of having to keep track of the state and all that, you just yield, 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 yield. So that's my carrot to say, if you're not using them yet, start using them. The exercise on generators, I'm going to skip for now, and we might come back. But I want to show another example here. Now this example, my guess is, I'm not sure exactly how many, but maybe a third to half of you will go, this is really obvious, why are you showing this? And the other third to half of you will go, oh, I never thought of doing something like that. Some of you were trained with languages where you couldn't do this kind of thing, or have used other languages for enough years that you couldn't do this kind of thing, and you may have been trained by those other languages to not consider certain ways of solving problems. And part of what you need to do when you're getting up to over this hump that some of you are in, which is why you came to this tutorial, as you're starting to learn Python, is
keep broadening your imagination. Go out there and read posts and code and examples to say, oh, I could solve this problem that way, so that they start being what you think about regularly. Here's a quick little toy example that's kind of fun. I'm going to design a calculator that takes 3 characters as input. And here's, to get there, I'm going to say, okay, 7 plus 3 is 10, right? Well, I know there's an operator module which exposes the add operation as it gives it a name, which is operator.add. So I can call operator.add 7.3, and it does exactly the same thing as that. Okay? I can, let's put that in an expression. So presumably someone gives me a string and they want me to do the math on it. I can split the string, right, using tuple assignment. It tries to iterate through this thing, and it gets 3 values, and you saw that it actually called each one and even got a stop iteration and hid that from you. So now I've got left-hand side operator and right-hand side are 7, plus, and 3, which is getting close to looking like that, except we need ints instead of strings. So now I've got a 7, a plus sign as a string, and a 3. The int 3, the int 7, and a string, which is the plus. Move them around so they look operator add. So I've got the order even right now. So I can do that. It's very similar order, right? I've got the operation and then the 2 arguments. And then I define a dictionary. And this is where some of you are going, oh yeah, right, obvious. And some of you are going, what? Oh, yeah, right. I guess you could solve it that way too, couldn't you? All right, so I'm going to say, when you see a plus sign, go look up in the dictionary based on that key and get me back a function and call the function. Right? So I'm going to look up the operator, get operator add back. This whole side here is going to be the function. I'm going to call the function with 2 arguments and get back the result. And I'll throw all that into a tiny little function. And now I can do my math. Right? And you're like, well, yeah, one if statement would have done just as well, or 2, I guess. All right? Until scope creep comes in, and the client, whoever they are, internal, external, yourself, says, oh, wait, no, we need to do /2, right? We want divide to be in here. And that's where you start to see the power. And again, when you run into cases where this makes sense, you're like, oh, right, we could do, once I've done it this way, then adding 1,000 more operations. Not a good example for a calculator, but, or maybe it is. All you do is something like that, and the function works now, right? So again, just toy example to say, imagine different ways of solving problems when using Python than other language you may have been coming from, right? And I've seen lots of code that solved with, I've seen lots of examples where someone was given a problem like this and they solved it with if, then, else. And again, it wasn't a calculator, it was something much more complicated. It was, happened to be initializing WebSphere and migrating a whole bunch of stuff with WZadmin, and it was, I'm just reading this code, and I'm like, it could have been like this with a table that big. And then you get rid of all sorts of errors because it's much smaller. And is it code or data? Well, dynamic languages like Python kind of blur those lines a little bit. Let me show you another example of using the features that Python exposes for you. Now, one of the sections we skipped, and I said go back to it later, shows you that when you use the, remember, I defined under get item and it was passed as 0. Well, it's actually passed, when you use square brackets on a list, for example, Python actually constructs a slice object and passes it to the get item method. And if you have, especially like, 2 or 3, 1 or 2 colons in there. And so what I'm going to do is I'm going to create an unpacker class. And I actually did this. We had a bunch of files that were defined with mainframe formats, and we need to access them. We had reams of documentation for like 40 different formats, and we wanted a way to do this easily, and so I wrote a library that did something very similar to this, but it had more features. So what I'm going to say is I'm going to dictionary where I've got slices. So a slice 0,3 is the same as square bracket 0:3, close square bracket. Give me 0, 1, and 2. Stop before you get to 3. And I got a trailer, and I got a middle. And definite's just going to save the thing in a record attribute. And then I'm going to override getAtter. All right? So when I call that, U is now going to have its record attribute be that string. And when I say U.header, what's going to happen is Python's going to go look for it and say, there's no header attribute in that instance. But let me go check to see if the parent, see if there's a getAttr somewhere up there. And I said, oh, here's a getAttr. Well, I'm going to call getAttr with U, and attr is going to be the string, quote, header, quote, right? It's going to be a string header, not the, like the name gets turned into a string by it gets in here. And so attr now references the same string, which is header. And then it checks in here. I say, okay, let's see, is the string header in this dictionary? If it is, then I'm going to call getItem. I'm going to dereference. I'm going to say, go look in record, which is this string, and get me out character 0 up to, but not including character 3. Right? So I say U.header and I get ABC. And I say U.trailer and I got that. I say U.middle and it gives me that. Right? So this was kind of hard. Had to do a little thinking about it, make sure I get weird error conditions right. This was easy. And again, with, like I said, like 30 or 40 definition files, and each one had 50 on average attributes, well, then it made sense to do that work up front, and then we could easily write Python code that accessed these things by name instead of by weird offset numbers. Right? So a couple examples there. So we've got one section left, one set of exercises, and we're on track to finish, and we might have time to go back and do some of those generator exercises. Any questions? Okay. Closures, partial functions, etc. So we hinted at some of this before. Let me be a little more methodically go through this. Toy example again, sorry. It's the way it always is in teaching typically. I have a function that I give it a message and I tell it what subsystem I want to log to, right? This has to do with something. And so all I'm going to do is print, log, whatever the subsystem and the message, right? Of course, typically I'd go write it to a file or something. And so this is a server kind of thing. I'm initializing it. I'm reading the config file. I'm just going into the log file. Okay. I could do that. Right? It's quite straightforward, right? I'm calling it over and over again. I'm putting this server argument in lots of places. Well, let's just put it in one place and factor it out and have this function called server log. Pass it a message, it does a server log where in whatever that means. Right? Okay, no surprises there. Oh. Okay, so I can do that with functools instead if I want. Instead of doing it myself, I can just call the functools module. Sorry, I can import the functools module, call its partial callable, which may or not be a function. One is I can call it like it's a function. I can pass it the function I defined and say, I want you to give me a new function, which is that function, but with this parameter already bound ahead of time.
Anyone know about a half hour rate?
Oh, you mean for the survey? Yeah, thanks. Right, so this is going to do exactly the same thing I did up there with this. It's just going to pre-bind. It's going to say server. I always want to call log with subsystem as server in the function that you return that is going to be saved. I'm going to save it in the name server log, overriding the one that was server log there. And I can look at that thing, and it's a partial function, functools partial object, and it's got a func in there, and it's got some keywords. So behind the scenes, it's doing something. And if you go look at it, just go to the standard library and open up the functools module, you can go read about it. And you can see that it's actually, I skimmed it, or just glanced at it. I think it's probably using, I'm not sure, it's using wrappers or dunder call or something like that. But the point is it's making it easy for you to do this. Okay. So there's another way. Here's another example of another way to do this. It's a sentence if it ends with a dot, a question mark, a period, a question mark, or an exclamation point. Right? Right, so because the exclamation point is in sentence ending, period is in sentence ending. Or I could just call dunder contains directly as a method on, so these are the same. One's using the standard keyword, one's using the method that implements code that in uses. So earlier when I said in uses getItem, well actually doesn't use it directly, right? So a sentence ending contains period is true, comma, nope, sentences don't end with commas. So what did sentence ending dot contains? What is that? Do you remember? Method. More precise, please. A bound method. Right. Up here I did some binding with functional partial, functors partial. Well, here I'm doing a bound method. And I can call it. Right? So why might you, here's an example of where you might actually do something with that bound method that we got earlier. Trivial example, but there are some better ones in real code out there. Okay? So is sentence ending is a bound method that means it already has the first argument to contains bound to sentence ending, which is that string up there. Okay? And I keep hinting at this callable thing. Well, let me show you another way to do this. So what's happening here is I created a class. It's got a dunder init. This is all straightforward. Now I'm using dunder call. Anyone here ever, how many people have written a dunder call? A couple, yeah? Oh, quite a few. So what this means is, what is sentence one? What type would that be if I checked? It's an instance of sentence ending object, yep. And is an instance, I can treat it like it's a function because it's got a dunder call. I could check to see if it's callable by using the callable built-in function, which by the way disappeared in 3.0 and 3.1's back in 3.2 or something like that. So I could check, is it callable? And it would say yes. And then when I call that function, what it does is Python says, oh, this is an object. You're trying to call me like a method or a function. Let me go check. So it goes up the chain and finds right there in the superclass, the class of this instance, it finds the call method and self and whatever its argument. So this is a test, is the sentence. It does this thing and it returns true. Okay, so here's a third way to sort of bind something. Here the binding is happening through a class instance, right? The class instance has the punctuation. And then if I do a is sentence, right, true and false, because I passed it only the period, right? And then I can say, well, let's give me a different one. And that one's better, right? So now I have two instances of this class, one of which thinks that punctuation, saved here in self.punctuation, is just the period, the other of which thinks it's all three of these. And in both cases, I can call this one like a function and this one like a function, but they're different functions. They have different behavior, the behavior based on what I bound in that data. Okay? All right. So, at this point, I have three things I'd like you to do in the next 13 minutes. Not 13 minutes, sorry, 7 minutes. We have 7 minutes left. Please fill out the survey, which is about this tutorial specifically and about all the tutorials generally, and it's really helpful to get good feedback on that. If you promise to do it later, you don't have to do it now, but I'd prefer you just take a couple minutes now. And then the other thing is, at the bottom of page 30 is an interesting exercise with named tuples and operator that teaches you a little about item getter and adder getter and a few things that you may or may not know about. Or if you prefer, if you look at that and say, oh, I know all that, you can go back and do the exercise on generators if you think that would be a more effective use of your time for the next few minutes. All right? So that concludes my formal standing up here and talking to you. Thank you very much for coming. Don't leave yet, because you've still got 7 minutes. I want you to do these things. I hope you learned some stuff. Give me honest, frank feedback. Tell me what I did wrong so I can fix it for next time. That's why this is as good as it is, because people have told me in the past things. And I hope this helps you become more proficient with Python.